Hello Year 10s, this is Mrs. Elliott. This is my hand, and I'm going to take you through the exam style questions at the end of chapter 1 of the Further Maths book. They're all on number topics, and I'm just going through them in case you had any problems with them. Obviously fast forward through this to any question that you actually have. You don't have to watch the whole thing. The questions in this chapter are on fractions. There is one there on standard form, a couple on percentages, and one on surds. Okay, so I'm going to start off with the fractions question, which was number 1. So we've got 2.5 plus 1 2/3 equals 3 3/4 times k. So immediately I'm looking at it and thinking I prefer to do fractions questions in improper fraction form rather than with mixed numbers. So I'm going to change from mixed numbers to improper fractions. So that will be 5/2. This will be 5/3. This will be 15/4. Okay, so I'm adding on this side of my equation, I'm adding fractions, so I need to have a common denominator. Lowest common denominator for these two would be a 6. So if I'm multiplying the denominator by 3, I have to multiply the numerator by 3, so that would be 15/6. Multiplying the denominator by 2 and the numerator by 2, that would be 10/6. Don't need to do anything on this side, just leave that as it is. Okay, so adding the two sixths up together on this side, I've got 25 sixths, and that's equal to 15/4k. So now this is just a simple equation. If I want to get k on its own, I need to divide by 15/4. So dividing both sides by 15/4, that will get me to k. Remember, when you divide by a fraction, that's the same as multiplying by its reciprocal. So 25/6 times 4/15, the reciprocal, equals k. So now just do a little bit of cancelling to make my multiplication a bit simpler. 2 and a 3. So I'm going to end up with 50/45. It's going to be my k. 5's going to both of those, that's 10/9 is equal to k. Now my original question was in terms of mixed numbers, so I'll make that into a mixed number. So that's 1 1/9 for my answer. What makes this, I think, a further maths question, it's probably that it's got a bit of everything in it. It's got a bit of changing from mixed numbers to improper fractions. It's got a adding of fractions. It's got a k over here, which turns it into a bit of an equation. Here we've got to divide by a fraction, which means we have to multiply by the reciprocal. I think it's probably just got a few bits in it, which is why it's a further maths question. Hopefully that was okay. Right, I'll move on to question 2. If I can get my ball to rub out. Now with question 2, it looks like we've got a standard form type question. So we've got light. Light is travelling at 3.00 times 10 to the, let me read this carefully, 10 to the 8 meters per second. And part A of the question is asking how many kilometers does light travel in 1 hour, and give my answer in standard form. Okay, so I want to know how far my light can travel in an hour. At the moment, I've got it in seconds. So in a minute, there are 60 seconds. In an hour, there are 3,600, 60 times 60. So my light can travel at 3,600 times this, 3.00 times 10 to the 8 meters in an hour. Yeah, so that's just 60 times 60 to take us from seconds through minutes to hours. Yeah, 3,600 times 3, that's 10,800 times 10 to the 8 meters in an hour. Now at the moment this isn't in standard form, So I'm going to put this number here into standard form to start with. So 10,800 is the same as 1.08 times 10 to the 4. And I've got here times 10 to the 8. That's meters per hour. And that gives me 1.08 times 10 to the 12 meters per hour. Now that is the number that's in the back of the book as the answer. Now I think that's wrong. I think what they haven't done in the back of the book is actually answered the question. They've given you meters that light can travel in an hour. The question asks, how many kilometers does light travel in 1 hour? So to get to that, we need to think about how many meters there are in a kilometre. So 1 kilometre, we know, equals 1,000 metres, which is 10 to the 3 metres. So what we need to do with our 1.08 times 10 to the 12, we need to divide it by 10 to the 3. So 1.08 times 10 to the 12 divided by 10 to the 3 will give us how many kilometres we travel in an hour. Now, if you remember the rule for powers, I've got a 10 to the 12 divided by a 10 to the 3. 10 to the 12 divided by 10 to the 3, what we do is we subtract the 3 from the 12. So that's going to give me 1.08 times 10 to the 9 metres kilometres, in an hour, which was what the question actually asked for. Okay, so I think that answer in the back of the book is wrong. I think that answer there is right. Second part of the question, part B. How long does light take to travel 1 metre? Give your answer in standard form again to 3 significant figures. So we know that our speed of light is 3 times 10 to the 8 metres per second. And we know our our formula for speed. Speed equals distance over time. You may have learnt this using the triangle. Speed, distance, time. Yeah. Okay, we want to know how long it takes for light to travel 1 metre. So we know our distance, we know that's a metre. We know our speed, which is 3 times 10 to the 8. We just need to find our time. So here we're going to use this formula as time equals distance over speed, which in this case is 1 metre divided by 3 times 10 to the 8. 3 times 10 to the 8 is on the denominator. So we need to sort of set this up so that we recognise that it's on the denominator. We do this as 1 over 3 multiplied by 1 over 10 to the 8. That's going to give us a third times 10 to the minus 8. Remember that rule that we have for a power on the denominator? It's a negative power. A third in decimal form is a 0.333 to 3 significant figures times 10 to the minus 8. Now that isn't quite in standard form. What we need for standard form is for this number to be between 1 and 10. So that's going to be 3.33. That's just to 3 significant figures. Now we've multiplied this number by 10. So to keep the whole thing the same, we need to divide this number by 10, which means that's going to be 3.33 times 10 to the minus 9. I'm just going to check my camera for a second, just to check that that fitted on the... Oh yeah, it did, just about fitted on the screen there. Okay, so using time as distance over speed, distance is 1 metre, speed is 3 times 10 to the 8, so that's on the denominator. That's a third times 1 over 10 to the 8, which is 0.333 times 10 to the minus 8, which is 3.33 times 10 to the minus 9. Okay, that's question 2. Question 3 is a percentages question by the looks of it. A percentages and a ratios question, sort of all in one go. So we've got some boys and girls in a sports club. Oh, that's not working very well. Okay, question 3. Number of boys in a sports club apparently has increased by 35%. The number of girls in the sports club has decreased by 10%. There are now equal numbers of boys and girls in the club. What was the original ratio of boys to girls? So our original ratio of boys to girls would be B to G, like that. Yeah. So we've said our number of boys in the sports club has increased by 35%. So we want a multiplier for an increase of 35%. So that's going to be 1.35. 1.35 times the number of boys. We now know that that's equal to the number of girls, but the number of girls has decreased by 10%. A multiplier for a decrease of 10% is 0.9. So we know that 1.35 times the original number of boys is equal to 0.9 times the original number of girls. Now we want to rearrange this so that we've got the numbers on one side and the B's and G's on the other side. So I'm going to divide through by 0.9 and I'm going to divide through by B. Gives me G over B. Looking at these two, 0.45 goes into 0.9 twice. And it goes into 1.35 3 times. So 3 over 2 is G over B, which means my ratio of boys to girls is 3 to 2. So girls to boys rather, is 3 to 2. Or if we do it the other way around, boys to girls is 2 to 3. Yeah. Okay, so a bit of a ratios question, a little bit of a percentage multipliers question as well. Okay, next one, question 4. Over a year, the price of petrol has increased from 122.9 to 136.8. The price of a litre has increased by the same proportion. It's now 155.3. Find the price of diesel a year ago. Okay, so to find our multiplier for the increase going from 122.9 to 136.8, we put our original price on our denominator and our new price or our current price on the numerator. So our original price was 122.9 and our new one is 136.8. The ratio of the new price to the original price will give us a multiplier, and that multiplier will tell us what our increase is. So 136.8 divided by 122.9, that gives me 1.1131 and a few more decimals. So our increase in price is actually an 11.31% increase, going from 122.9. If you multiply by 1.1131, you'd get to 136.8. Now they've said the same thing has happened with diesel. Diesel has gone up by the same proportion. So that means that our new price divided by our original price will give us 1.1131. So our new price for the diesel is 155.3. Our original price is X, and that's going to give us 1.1131. So 155.3 over 1.1131 will give us our price of our original price of our diesel, and that is going to be, and I'm just using the answer button on my calculator, that's going to give me 139.52 pence per litre. So that's my price of diesel a year ago. Yeah, again, it's a multiplier question. How do you get your multiplier? New price over the original price. If the new price had been lower, then our multiplier would have been less than 1, which would have been the correct thing for a multiplier showing a decrease in price. Okay, last question. Last question is a surds question. We all love a surds question. Plenty of surds in our further maths. So, last question, number 5. X is 2 minus root 5 and y is 4 minus root 5 in this question. We want some answers in the form p plus q root 5, where p and q are rational numbers. Remember, a rational number is a fraction or a whole number, but a fraction is allowed as a rational number. So first of all, part A, we're going to find xy. So xy is going to be our x multiplied by our y. And we just multiply this out as if we were multiplying out brackets in algebra. So 2 times 4 is 8. 2 times minus root 5 is minus 2 root 5. 4 times minus 5 is minus 4 root 5. And then minus root 5 times minus root 5 is going to be plus 5. Yeah, double negative. So the plus root 5 times root 5 is 5. Adding the whole numbers together, that's 13. And the surds part, we've got minus 2 root 5s and minus 4 root 5. So altogether we've got minus 6 root 5s. So that is in this format that was required. The p is the 13, the q is the minus 6. Part B of the question is an x over y. And so we just write in our x and y's, and 2 minus root 5 for our x, and 4 minus root 5 for our y's. Now, this is one of those questions where we've got a surd on the denominator of a fraction. We don't like having a surd on the denominator of a fraction, so we want to rationalise it. When we've got our surd in this form, 4 minus the surd, we use our knowledge of difference of two squares to multiply both the denominator and the numerator of the fraction by the other part of the difference of two squares, which will be a 4 plus root 5. That will show you as a reminder. So 2 minus root 5 on the top is going to be multiplied by 4 plus root 5. Remember, we've got to multiply the top and bottom of our fraction by the same thing in order that our fraction stays the same. And there we go. And now we just multiply out our numerator, same sort of method as we used for part A of the question. 2 times the 4 is 8. 2 times the plus root 5 is plus 2 root 5. 4 times minus root 5 is minus 4 root 5. Minus root 5 times root 5 is a minus 5 on that occasion. Now on the bottom we've got a difference of two squares, so the squares of the 4s are the 16. And then the 4 times root 5 and the 4 times minus root 5 will cancel out, and so we're going to have minus 5, minus root 5 times 5. Root 5, sorry, on the bottom there. Okay, just simplifying this. 8 minus 5 is a 3. 2 root 5 minus 4 root 5 is minus 2 root 5. And that's all over 11. Now that isn't quite in the format that has been asked for in the question. The question asked for it in this format here. So let's separate out our two parts. So our rational number on its own is just 3 over 11. And keeping the same denominator, our surd part is minus 2. Again, it's over 11 times the root 5. So hopefully that's explained any of those questions that you were having a problem with.